All right, welcome back to Mr. PL's with Precal. This is Unit 2, Topic 2. This is solving exponential logarithmic equations. Lesson number 2. So this happens to be what power of 5 is 125, and that would be 3. Natural log of e to the third power. Now keep in mind, natural log is log base e, so that really is the inverse of e to the power of. Or you can think of it as anything to the power of, when it's logs, you can power rule, you can push that to the coefficient spot. And then what power of e is e? That would be 1, and 1 times 3 is 3. Or you can just remember that if these are inverses of each other, then that's always going to be your answer. This is really log base 10 of 100, so of 1,000, sorry, so that would be 3 as well. So everything on top is 3, because 10 to the third power is 1,000. All right, so now this question, if I put this equal to x, 81 to the x power equals 3. Make this equal to the third, so 3 to the base of what power? So 3 times 3 is 9 times 3 is 27 times 3 is 81. So that's really 3 to the fourth power. And there's already an x there. Now that we have the exact same base, then we can basically do log base 3 of both sides. And that leaves us with 4x equals 1. So the answer is 1/4. This would be 10 to the fourth power equals x, which would be 10,000. 10, 100,000, 10,000, yep. And this would be 8 to the x power equals 16. So we can make these both base 2. So that's 2 to the 3x, and that's 2 to the fourth. And then divide both sides by 3, you get 4/3. Once again, the bases cancel. You're left with 3x equals 4. Divide both sides by 3. All right, which gets us to our actual part of the lesson. Oh, okay, so I just have solving on this one. Okay, solve each of the equations, round your answers to the nearest 10,000. So I'm going to do log base 17 of both sides. And so therefore, there's my answer. So I'm going to leave it like this. I know it says round your answers, but we're probably not going to be doing that because, yeah, you can put this in the calculator and you can see what it ends up being. And if you don't have a scientific calculator that does bases that are like this, like 17, then you can use change of base. You can say log of 62 divided by log of 17 by changing the base to base 10, and then that will give you your answer in a decimal form. But keep in mind, that's not going to be precise because that's going to be irrational. So I choose to leave it just like this because that's a precise answer. Same goes for all of these. So we have log base 9 of 39, and there's your answer. So all of these first questions are all pretty much exactly the same. So when we get to question number 9, now we get a little bit more. So we are going to do PEMDAS backwards because that's what you do when you solve equations. I'm going to divide both sides by 8. That gives me 13 to the 7x power equals 73 over 8. Then I'm going to do log base 13 to get rid of this base right here. Log base 13 of both sides. This is a decimal, so I'm going to leave it the way it is. That gives me 7x equals log base 13 of 73/8. And then I'm going to divide both sides by 7. And then there's your answer right there. I guess I'm going to keep this short because I'm missing the rest of my notes on this flip chart, which I added. Subtract 6 to both sides. I get e to the r plus 4 equals 23. Then do natural log of both sides. So I have r plus 4 equals natural log of 23. And then subtract 4 from both sides. Now this is important. So this is natural log of 23 in parentheses. And then the minus 4 goes on the outside because that's an up or down translation. It's not a part of the left or right transformation in this case. So that's on the outside, very important. So natural log of 23 minus 4 is your answer. Solve a couple more. I'll do number 16. So divide both sides by negative 10. That gives you 8 to the negative 5n power equals negative 81 over negative 10. Now, I can change these both to positive because negative divided by negative is a positive. Then do... not natural log, sorry, log base 8, log base 8 of both sides. So that gives me negative 5n equals log base 8 of 81 tenths, or 8.1 technically. So that I probably could simplify because it's not going to be irrational. And then divide both sides by negative 5, which dividing by negative 5 is the same as multiplying by 1/5. So I really get negative 1/5 times log base 8 of 8.1, and there's a very precise answer which you can then put into a graphic calculator. So if I do a little bit of skipping and Go to maybe like 21. This really isn't any different than any of the other questions I've been doing. So subtract 3 from both sides gives me 7e to the 2 minus 3x power equals 89. Then divide both sides by 7. You get e to the 2 minus 3x power equals 89 sevenths. And then you can do natural log of both sides. That's the inverse of e to the power of. So that leaves me with 2 minus 3x equals natural log of 89 sevenths. And then the next thing I would do is subtract 2 from both sides and then divide by negative 3. So there's your answer. So you end up getting negative 1/3 times natural log of 89 sevenths and then minus 2. Oh, okay. So the negative 1/3 has to be done to all of that. So I do need brackets because it has to be negative 1/3 of this included because that was the very, very last step. I want to make sure I include that in there. All right. I'm going to keep this one pretty short. Guess I'm going to have to make sure I focus on quadratic ones terms because that's really what this lesson was designed to do. Thanks again for watching. Have a great day.